The first MCAS topic that we're going to be reviewing is going to be number sense and operations. So we're going to go over a number of different topics within this large overview topic of number sense and operations, and we are just going to quickly go over some main things to remember about different things, and then look at a couple of examples. So first we're going to look at PEMDAS. So PEMDAS, you'll remember, is a way to remember order of operations. Now, rather than remembering it as PEMDAS, I'd like you to remember it such that M and D are together and A and S are together. So this order of operations really tells you that you want to start with parentheses, then exponents. Now, multiplication and division are actually the same level, but you want to do it from left to right. It is not that multiplication is necessarily first. Division could come first if it is on the left of the multiplication. So take a look at example 1. We have 2 squared plus 1 in parentheses minus 4 plus 18 divided by 2 times 3. So we'll start with what's inside the parentheses, so 2 squared plus 1. Now inside the parentheses, we'll start with the exponent. So 2 squared is 4 plus 1 is 5. And then from here, it looks like we're done with parentheses and exponents, so now you look at multiplication and division. Now, you do not do the 2 times 3 first. Instead, you're going to do 18 divided by 2 first, because that division appears to the left of the multiplication. So 18 divided by 2 is 9, then 9 times 3 is 27. Now, same thing with addition and subtraction. You want to do addition and subtraction as they appear from left to right. So we would do the 5 minus 4 first, which is 1, and then add 27, which will end up being 28. So 28 is our answer here. All right, next is absolute value. Now for absolute value, you can see this as acting as parentheses. So you want to simplify it inside the absolute value first before you actually take the absolute value. So take a look at example 2. If you're simplifying this expression here, the absolute value basically acts as a parenthesis. So you want to deal with the parentheses first before you take the absolute value and then do any other operations on that value. So with the negative 5 plus 2 times 3, we'll apply the order of operations inside of the absolute value. So 2 times 3 is first, and then negative 5 plus 6 is going to be 1. And the absolute value of 1 is 1. So this is just 4 plus 1, which is equal to 5. So our answer here is going to be 5. All right, next topic is exponents. So a couple of exponent rules to remember. When you're multiplying with the same base, you're going to add the exponents. When you're dividing things with the same base, you're going to subtract the exponents. And then when you have a power raised to a power, you're going to multiply those exponents. So take a look at example 3. We have x squared to the third times x to the fourth. Now you'll notice that we have a parentheses in there, and we actually have a power to a power. So x to the second to the third. Right, that's a power to a power. So if you have a power to a power, you're going to multiply those exponents. So we have x to the sixth times x to the fourth. And now you're multiplying things with the same base. So now we're going to add those exponents. So x to the sixth times x to the fourth is going to be x to the 10th. And that's as simplified as we can get this expression. All right, and then next topic will be radicals. So radicals are the opposite operation of exponents. So just as if you raise something to the third power, the opposite operation of that would be taking the cube root, and so that is dealing with radicals. So take a look at example 4. We have the square root of 3 to the fourth power. You can write this out if you'd like as the square root of 3 multiplied by itself 4 times, and then simplify this as much as you can. So the square root of 3 times the square root of 3 is the square root of 9. So we have 2 pairs of those. So we actually have square root of 9 times square root of 9, which is simply the square root of 81, or the square root of 9 squared. The square root and the squared cancel, and that leaves you with 9. Another way to go about simplifying an expression like this is to rewrite the square root as a rational exponent. That means I would write it as 3 to the 1/2 and then to the 4th power. And then you would apply exponent rules and you would multiply a power to a power. So that would be 3 to the 1/2 times 4, which would be 3 squared, and 3 squared is equal to 9. All right, our next topic here is estimation. So take a look at this example. In a school, there are 212 freshmen, 196 sophomores, 204 juniors, and 208 seniors. If 24% of the students attended a dance where each ticket cost $19.95, what was the approximate total that was collected in ticket costs? All right, so you'll notice that because this is an estimation problem, we are going to want to approximate some values before we do any calculations. So it looks like there are about 200 students per class. So probably around 800 students total. So let's start there. Next, we're talking about 24% of the students attending the dance. 24% is about 1/4 of the students, right? It's very close to 25%, which is a quarter. So a quarter of 800 would be about 200 students. And then we're told that each ticket costs $19.95, so about $20. So if we want to know the approximate total that was collected in ticket costs, you would do 200 times 20, because there are about 200 students, we said. So 200 times $20 for each ticket, that's going to come out as about $4,000. All right, you may also see estimation problems show up like this next one. Estimate the value of the square root of 17 to the nearest 10th. So anytime you have a problem like this, you want to work with square roots of perfect squares. So square root of 17 is between the square root of 16 and the square root of 25. So I'm going to go ahead and draw those on the number line. Now we know the square root of 16 is 4 and the square root of 25 is 5. So we definitely know that the square root of 17 is going to be pretty close to 4. Now if we were to draw all these points in between 4 and 5, well, right halfway between would be 4.5. And so square root of 17 is going to be pretty close to 4.1. So again, with problems like these where you're asked to estimate a value where it's the square root of something that is not a square root, you want to start with square roots of perfect squares and use that to help you estimate around where your value is going to be. Okay, a couple of properties to remind you of. First is the commutative property. That's a plus b is equal to b plus a. That simply means that the order does not matter. Now the commutative property applies to addition. It also applies to multiplication, right? A times b is equal to b times a. It does not, however, apply to subtraction, right? A minus b is different from b minus a. Next, we have the associative property. So if we have 3 things that we are adding, it doesn't matter if we add the first 2 and then add the third one, or if we add the latter 2 and then the first one. So this also applies to multiplication as well. Next, we have the distributive property. And this says if you multiply a sum by some number a, it is the same as multiplying each of those numbers by a before you add them. All right, then we have the identity property. So the additive identity says that a plus 0 is equal to a. So 0 is what we call the additive identity. That means we add this number and we get back the same thing. Then the multiplicative identity, here we have a times 1 is equal to a. So if you multiply this number by 1, then you get back what you started with. So 1 is what we call the multiplicative identity. Next, we have some inverses. So the inverses, these are what you add to a certain number in order to get the identity. So for example, the additive inverse is negative a. The additive inverse of a is negative a because when you add those two together, you end up with 0, and 0 is the additive identity. Then we have the multiplicative inverse. So for a, that would be 1 over a. So when you multiply by the multiplicative inverse, you should get back the multiplicative identity, which is 1. So a times 1 over a gives you back 1. All right, next, example 3. What is the additive inverse of 29a? In other words, what do I add to 29a to get 0? Well, that has to be the opposite of 29a, which is negative 29a. So the additive inverse of 29a is negative 29a. All right, example 4. What is the property shown in the equation below? So we have 20 plus 4 times 32 is equal to 32 times 20 plus 4. Now, although you see the parentheses there, this is actually not showing the distributive property because we actually haven't distributed the 32 to the 20 and to the 4. If you look more closely, you'll notice that really what we've done is we've changed the order of the numbers that we are multiplying. So whenever we talk about order doesn't matter, you can swap the 20 plus 4 to be the second value that's being multiplied instead of the first. We're talking about the commutative property. So this is showing the commutative property here.